with purpose.
Thanks, Ron. Ben is one of a valuable member of WPTM. He is on level 1, and he's doing his second speech today. The purpose of the speech is writing a speech with purpose. The purpose of this project is for the member to learn or review basic methods of writing a speech with a defined purpose and to present a well-organized speech on any topic. The speech timelines are 5 to 7 minutes. So the timer, 5 minutes green, 6 minutes yellow, and 7 minutes red, and red stays until Ben finishes. The speech title is How Structures Work. How Structures Work. Ben, how structures work. Over to you.
Oh, and actually, before Ben starts, I should mention that he had emailed that the timing of this particular speech is 8 to 10 minutes. So, Cindy, we probably have the green come on at 8, 9 for yellow, and red at 10. And Shirley has raised her hand just so that her screen shows up permanently. So when the colors change, Ben should see it. Although Ben tells me as well that he had a PowerPoint, so hopefully he can still see Shirley's colors.
I can move Shirley onto the other screen. It should be fine.
Okay, sounds good. All right. So without further ado, how structures work, Ben Dashistani.
Thank you so much, Mr. Toastmaster. Could I get a confirmation that you can see this screen of mine?
I can see it.
Wonderful. Okay. Thank you, everybody. Welcome. I really appreciate the opportunity to present on how structures work. This is a topic that's close to my heart as I am a structural engineer. Now, some of the objectives of this presentation are to give you insights into the fundamentals of the structures and hopefully make you see structures a little bit differently than you see them in your day-to-day life. My objectives are not to make you read through the National Building Code. That's always boring. To make you do any calculations. I hate doing those myself. To make you an expert in structural. I'm by no means an expert. And to make you fall asleep, of course. Hopefully you'll be vibrant and awake. Now, what is a structure? I often ask myself this every day. I'm a big dog lover, as you can see. So are dogs or cats structures, you may ask yourself? So the simplest definition of a structure is just the system of simple components. This definition can apply to many objects and beings as well. So dogs are structures, cats are structures. What structures do engineers, such as myself, care about? So you see photos here of an oil rig. There's a bridge there with a dog on it. So which ones do engineers care about? And the simplest answer is basically any of them. Bridges, oil rigs, towers like you see here. And the main purpose of a structure is to support at least one load. And load is basically any force or any pressure. And oftentimes, engineers are brought in to protect the safety of the public. And these structures do affect the safety of the public because they're the users. Now, what are some of these types of structures? They're places we work and learn. I'm in an office right now. Places where we live and play. If you live in an apartment or a house, those are all structures. If you go to the gym, that's a structure. One fun fact I like to share about dogs, in my home province of Ontario, pit bulls have actually been fully banned. And I like to share this fun dog fact, not because, I have anything against pit bulls, but pit bulls are oftentimes, if they're not properly bred or if they're not properly trained, can be very aggressive. So just in case, if you're ever in Ontario or Winnipeg and you happen to have a purebred pit bull, please keep that out of the province and out of the city of Winnipeg. Just a public safety announcement. Now, what are the loads I was talking about earlier? So forces, that's either a push or a pull, just to put it simply. You don't have to worry about the units. Units are Newton. If you're not familiar with that, that's all good. Moments, torque, that's bending or twisting. So anything that tends to bend something or twist it, that is a moment or torque. Oftentimes, structural engineers use the term moment. In the public, oftentimes torque is used more often. That has units of force times distance, but again, that's something we don't have to keep in mind right now. Now, what loads are typically applied to a structure? That is oftentimes the first question I ask myself when I'm designing any bridge, any pipe rack, any platform structure, and that is the first step of what we call structural analysis. So we oftentimes have dead loads, so that's basically anything that's permanently on the structure. If you're like me and you have some lazy relatives that sleep on your couch a lot, those are also dead loads. but anything that refuses to move is basically a dead load. Live loads, again, very simple. Those are moving, so cars on a bridge. If you have pets that run around the house, if you run around the house, you're a live load, and engineers have to keep that in mind when designing any structure. Wind loads, again, very simple. That's basically based on the geographic location, the wind load that is being applied to a structure. We have to look at that and make sure a structure is not behaving like what you see there on the right. That's a famous example of the Tacoma Narrows Bridge, which was unfortunately vibrating a lot, and it led to its eventual collapse. Snow rain loads, again, these are varying by location depending on the geography. We have to consider those on a bridge or basically on a tower or on any type of structure that basically is outdoors. Now, 1 in 50 years versus 1 in 30 years, that's something you'll hear engineers use a lot. That, again, is dependent more on geographic location. Earthquake loads. So earthquake loads are, again, very much a factor depending on the location around the globe. So in British Columbia, for example, in Canada, that is often a big one we have to look at, and it involves looking at the structure as it's vibrating and not in static. So that is something we'll oftentimes look at if we're designing a structure for that particular location. Static versus dynamic analysis, just very high level. Static, we're just trying to make sure the structure is stationary. The loads are not causing any vibration. Dynamic analysis comes into play when you're trying to look at a structure and seeing how it will behave under vibration. So if the structure will stay affable, if it were. And oftentimes, the taller the structure is, the more vibration it will experience. And there's so many other types of loads. I don't have to go through all of them because I don't want to make you fall asleep. But again, as an engineer, you have to be aware of all of these and see which one applies to a particular structure. Now, hard loads transferred in a structure, again, very much high level through horizontal members, which are oftentimes called beams, vertical members, columns, all the way down to the foundation. Very simply put. Members, again, we have beams, which we treat primarily as one-dimensional. Same thing with columns. You have slabs or plates. Those are when you have concrete members, and walls are load-bearing. Those are usually for masonry-type structures. That is something that we look at very rarely in the industrial side of things, but in residential and commercial, those become very applicable. Types of foundations, you have shallow foundations, which are basically transferring loads to the basically shallow soil layers, and you have deep foundation piles. I think folks are very familiar with. Those are basically shafts or concrete piles that go deep into the greater soil layers, and that's how those foundation loads are transferred. It depends on the location again. I don't need to get into it, just to kind of give you a high level of what they are. Now, different structural design philosophies. There's allowable stress design. If you've heard about this, this is where we apply a factor of safety. So if, for example, something is being designed to have a factor of safety 2, that means it should have a resistance of twice of the load that's being applied to it. This oftentimes leads to very bulky structures. So most of the old structures are designed this way. It's a famous building in Chicago that has that design philosophy. The limit states design, that is a newer design philosophy where we basically reduce the allowable resistance of the structure by a certain percentage. And this leads to very efficient structures such as the tower that you see right there. That's one of the famous towers on Billionaires Row in Manhattan. And very tall, very narrow, very efficient. And generally, how our structure size, this is the only formula in the presentation, but stress equals force divided by area. So we find the forces, we calculate those, and then based on allowable stress, which is dependent on the material, we can size the members, so the area. And one of the examples I like to use is basically if you think about dogs, for example, I have a Rottweiler here and a Chihuahua. So again, they're both, same material, they're made of the same materials, but the Rottweiler has a greater capacity for strength because it has more muscle, right? So same thing with structural members. The larger cross-sectional area they have, the greater strength it will have. So similar kind of analogy. And some of the common structural materials, structural steel, you'll see a lot in different towers, different malls, and it's very high strength. It has a very good capacity for loads. However, it is susceptible to corrosion and fire, unfortunately, basically like spaghetti. So that is one thing we struggle with. Reinforced concrete, very great fire resistance. Unfortunately, it's very good in compression, so where you're squeezing it. Very weak if you're pulling it apart. So that is something also we struggle with as structural engineers. Timber is one that's often used for housing, small houses, not really in large structures. Masonry, that's, bricks, cylinder blocks, that has excellent fire resistance. A lot of people like the look of it. It's not as efficient, so it's usually older buildings will have it, newer buildings not as much. And we have some specialty materials. For example, if you've ever wondered why nuclear cooling towers can withstand such high temperatures, it's because it's a special type of concrete. You can see photos there on the left. Regular concrete, unfortunately, breaks apart on high temperatures. This specialized concrete, which has an aluminum substitute in it, can withstand very high temperatures. So you'll get the very nice thermal resistance that you're looking for nuclear cooling towers. Now, I often like to also bring up this topic of structural aesthetics, because as structural engineers, sometimes we're not concerned with how something looks, but I like to look at it from a design perspective as well. Why do some structures look more beautiful? Why do some structures strike us as looking, complex or ugly? And the answer lies in simplicity and symmetry. So most structures that we find, this looks pleasant, oftentimes it's very simple, it's very symmetric. On the other hand, if you have asymmetry, if you have complexity, oftentimes the regular public or just an average person on the street will think, the structure doesn't look pleasant at all. And just to keep in mind, simplicity and symmetry oftentimes make the structural engineer's job easier, simpler analysis, simpler design. So that is oftentimes one thing to look at from our perspective. Again, asymmetry, a structure such as this one, which I believe is a museum somewhere in the States, this would actually involve a lot of detailed analysis work to make this structure function properly. Architects love this kind of thing. It makes the lives of engineers very difficult. But again, sometimes you can argue about the beauty, like the aesthetics of it. My perspective is this would be a nightmare to design, and I try to stay away from structures such as these. That's why I work for Worley, where we stick to industrial and everything's simple. Now, just a overall summary, structural engineering is not meant to be complicated. If it was, I wouldn't be doing it. You break the structure into simpler elements. You make sure that you're following the appropriate codes, because those are laws, and keep the design as simple as possible. And two questions I always bring it back to: what loads are being applied to the structure? And can the structure withstand the loads? Does it have the proper resistance? Thank you very much. That summarizes the speech. I'll open it up for questions.
Thank you very much, Ben. Were you looking for questions from the audience, or that's just part of your presentation?
That was just part of the end of the speech. Yeah, I appreciate it.
Okay, just checking.
Questions are welcome.
Excellent. Okay, if you're ready, go right ahead.
Ben, I believe it's 2 to 3 minutes, right, Shirley?
Yeah.
Thank you. Ben, loved your speech. It's always a pleasure to listen to all the presentation you do. Very well done. This is how I'm going to evaluate your speech. What things you did good, some improvements, and then the best part of your speech, which I loved. And this is only a personal evaluation. I'm not an engineer myself. So make sure when you take the evaluation, keep that in mind. Okay, very good in the introduction. You added a lot of humor to it, showing interesting pictures and everything. The purpose of the project is met. The writing a speech with purpose, that purpose is met. Well-organized speech, well-delivered speech, use the props, use the presentation, use the slides in such a way that can support your speech. Some improvements that you can do to your speech is you started. There's very few improvements. You can pause in between if you want. I think I'm not an engineer. As a non-engineer like me, it was like a breeze. But if you are presenting it to structural engineers, they might find it slow. So take that evaluation in that spirit. Second thing is you started the speech with thanking everyone. Toastmasters say that we have to be thankful to you. Don't start the speech by thanking the audience. So keep that in mind. It's also a suggestion. Again, I never know. Engineers want to stay thankful. I'm not sure. I married one. I never thought that will be the thing. But the other thing I liked about is I'm a non-engineer, so your presentation was very informative to me. I learned a lot of new things, just like earthquake loads, structural elements, shallow and deep foundation, a lot of other new things that I would have add to my knowledge base, which is very good. the most important thing, most interesting thing in your whole thing, I thought was the structural aesthetics, because I'm a creative person. I like to see interesting designs. So I love that part of your presentation, although you said that it's a nightmare for engineers, architects loves it. But I loved that part. The best part of your speech was the dog and cat pictures. So beautiful pictures to support your presentation. Even anyone who listens to it will definitely have to look at those pictures, even though the subject was super boring to me, but you will look at that picture for sure. The pit bull analogy with the public safety announcement was the culmination of that presentation. Overall, Ben, the presentation was awesome, and I'm looking forward to listening more speeches from you. Over to you, Ron.
Thank you, Sakna. That was an excellent evaluation. We will now roll into our table topic section of the program. The timing we have in our agenda is a bit off in terms of shows us ending at 12:52, so we should have time for, I would think, 2 table topics. And our table topic master today is none other than Cindy Herger. Cindy's been a member of the club since before I was a member of the club, and is a wonderful person and our VP of membership within Health Masters. Please help me welcome Cindy Herger.
Thank you, Ron. Awesome introduction. I appreciate that. I have the purpose of Table Topic Master today, which we all, just as a quick brief overview, gives us the opportunity, particularly those of us who haven't had more presentation time, to present and to speak off the cuff, so to speak. That's without preparation and learning how to not have to stumble along as we respond to those unexpected conversations. So 2 minutes is what we aim for. We will ask for the green light at 1, the yellow at 1.5, and the red at 2. And we try to have people encouraged to speak at least up to that 1 minute and no longer than the 2.5 minutes. Yes, Ron?
I was just going to say, I'm not sure if you noticed at the beginning of the meeting, but Salva doesn't have any roles assigned to him.
Yes, I appreciate you pointing that out, because I do find it hard to determine along the way here. So thank you for that.
And Jeb doesn't either, but I don't know whether he was able to speak or not. We can ask him.
Jeanette as well. Is that somebody? Anyway, I will start with Jeb. Would I be able to have you respond as a first contributor?
Sure, yeah. I'm assuming this is table topics, so yeah. I'm doing like 3 things at the same time.
That's okay. Are you
you could also call Priyash.
Right, yeah. And I have 2 probably at least, so I will do that. Thank you. Well, if Jeb, you're 2 over, that's fine.
I mean, you got my attention now. I can get the table topics.
Yeah. Sticking with the theme, I am going to somewhat that Greg introduced to nature. I believe all of us have a true nature of continuous growth and learning. And so those of you that do get to know me know that I'm a personal development guru, kind of continuing to grow. My little approach here to table topics being quick is I'm going to give the name, I'll try to show it to you, of a book, the author, and then you give us that response of what do you believe that book is about. Make it up. We know that table topics can be whatever you want. So this one, I'm not sure if you can see it, is Excuses Be Gone. It is by Wayne Dyer. And so you're on to it, Jeb. What is that book about?
Well, thank you, Madam Table Topics Master. Fellow Toastmasters, our welcome guest. I have the opportunity to talk about this amazing book, Excuses Be Gone. So what this book is really about is our self-limiting thoughts, right? Which can be one of the primary impediments to people making the personal growth that they want to make for themselves. I know that everybody here in this room, we're all people who take personal growth very seriously. But one of the things that can really stop us from achieving our goals, our personal growth goals, is these self-limiting beliefs that we'll have. We will create excuses for ourselves. And I believe that these excuses are often tied to our sense of identity. We might say, oh, I'm not the kind of person who would be very good at that. Or, oh, I don't think that is specifically for me. I think it's just human nature that we like to stay within our comfort zone, and nobody really likes failing. That's not a very good feeling, right? So if there's something that we feel we're not naturally gifted at, or we don't have a particular amount of experience, we just kind of want to avoid doing it. But the secret is that's where the most growth happens, right? If you have a little Venn diagram, you can go like, here's your comfort zone. And then there's a dot outside that goes, here's where the magic happens, right? The magic happens with regards to personal growth outside of your comfort zone. And I think that is kind of what this book talks about, right? Don't have limiting beliefs about who you are and what you have to offer the world. Go and explore that. That is where the magic happens. That is where you will find your gift that you can give to the world, and where you will see the most gains in your personal improvement journey. So stop with the excuses and go out there and be the best version of yourself you can be by not having any limiting ideas about who you are and what you have to offer the world.
Good job. Thank you, Jim. You've hidden that you read this already, right?
I've never heard of this book before.
Thank you. And Jonathan, just so you know, you will be evaluating, I gather, too. But we have time for perhaps one more. So we will call on, sorry, I'm trying to find the names. Prayesh, are you okay to contribute
Yes.
to table
Yeah.
topics? Okay. So as you heard my reference, the next book for you to describe is The Monk Who Sold His Ferrari by Robin Sharma. Not sure if you've heard of it, but let us hear what it's all about.
Yeah. Thank you, Miss Table Toastmaster and the fellow Toastmasters, and especially thank you, Jason. Um, A Monk Who Sold Ferrari is a book, is an amazing book actually that gives a perspective of life, and I'd like to give a few things from the book to you all. Um, for entire life, a person follows his dream and try to fulfill all the desires and try to satisfy their needs, necessities, which might not be the necessities they actually fail. So let me divide those necessities into two. Uh, Let me give an analogy of the pyramid. So we have basic necessities like food, shelter, clothing. Those are the base of the pyramid, and then we grow upwards. The necessities are more kind of luxuries which we might not need to survive. But due to societal pressure or due to, let's say, comparison, people try to follow those, and which is also needed in our life to grow. But when it becomes negative, it brings more problem than benefits. So the book, A Monk Who Sold His Ferrari, gives the gist about all these ideas and concepts which limits us to our desires and just focus on the objective objects in our life. So he gives the idea like he sold his Ferrari and he is more relaxed. So he got the experience of how the things are, but what is the actual meaning of life? So give, and he also gives some tips to what he feels on it. So after selling his Ferrari, he feels more contempt, and he has the great sense of life, spending time with family, doing some good work for the society, helping others, and giving away what he possibly can to society gives the uh, more pleasure to our life and bring it more happy. Uh, that's the that's the gist of the book. I would like to say. Thank you.
Good job. Thank you so much, Priyash. Sorry, and thank you for doing that response. You guys both, it shows you well-titled books because you both kind of targeted exactly what they're close to what they're about. So good depth, encourage their reading if anybody's interested. And over to, I believe directly, do we go to our evaluator, Jonathan, correct?
Yeah, let's do that. Or actually, well, we could
To the
do. We could go
GE.
to either Jonathan or Jason. If Jason wants to call Jonathan to do the table topic evaluations, it's up to Jason. You want to just roll into the GE section of the program?
Okay, yes. Okay,
Okay,
we'll
let's do
move
that.
on into evaluation, and I won't, and I'll just get to the point here and call Jonathan to give an evaluation of our two table topic speakers, as we are running short of time. Jonathan, please, and give him the green at 2, the yellow at 2.5, and the red at 3. Thank you.
Well, thank you, Mr. General Evaluator. Wow, that was a great table topic session. And after hearing the two responses, for which I was actually quite mesmerized about, I wish we had more time for this table topics. I'm looking forward to more and more of these kind of very creative, on the spot generated responses. Cindy, I thought you were very structurally sound in terms of preparing for this role as the table topics evaluator. You explained the timing instructions. I think you were probably on your way to doing this, but Ron gave a good reminder to try to target people who do not have roles to respond, so everyone gets a fair chance to talk. And I thought you also took a really creative way to approach table topics evaluation. It really encourages people to think on their feet and just be very creative. One suggestion I can make, if I can make one, is one thing we do for WPTM is the table topics evaluator master usually gives some hints on how to think about, formulate your ideas and structure your response prior to asking the questions, just so for those of us who are newer to it, they have a little bit of guidance. But I thought you did an amazing job. Jeb, you're the first responder, and your book was Excuses Be Gone by Wayne Dyer. And Jeb, I could have sworn that you actually read this book, and how you described it. It flowed really well. You spoke with a passion and a demeanor of which kind of exude confidence. So then we were very drawn to it. You said you related to all of us in the beginning. You're saying we all take it personally. You always kind of brought it to everyone, so it drew everyone's attention because we can relate. You gave some examples about how we create excuses, and it's tied to a sense of identity. And then you started using things like Venn diagrams and using your gestures, and it just really gave a really dynamic speech. And you concluded the speech with a challenge to your audience, and you said, "Stop the excuse. Go be the best version of yourself." You ended with a challenge, and that's a really good way to conclude your speech. I actually struggled to find anything to really improve from your speech, so great job, Jeb. Prayesh, your response to the monk who sold his Ferrari, I think you did an amazing job in terms of coming up with a response too, talking about how the monk had you contrasted the basic necessities and luxuries. You kind of extrapolate on what the author was feeling in terms of why he did it, how he felt content. He was giving time and money to others. And I thought it was a really good on the spot response. The only small improvement I would suggest is I noticed that you were talking with your hands kind of held like this. Try to use your hands to support your speech so that it gives a little more dynamic feel. Great table topics. I look forward to more creative approaches like this one.